Hello, our group presentation will be over Bayes' rules and we'll be covering problem one. So the next few slides will be diving deeper into the rule and the final answers for problem one. Thank you, and I hope you enjoy. To better understand Bayes' rule, it's important to also understand what conditional probability is. So conditional probability is the likelihood of one event or proposition being true, given that another event is also known to be true. An example I like to use is if A equals it is raining, then B equals the ground is wet. One event is true, so the other has to be deemed true as well, presented by Mauricio Martinez. And if you still don't fully understand, that is perfectly okay because we can visualize conditional probability with this Venn diagram. Circle A represents the set of outcomes where event A occurs, and circle B represents the set of outcomes where event B occurs. In the overlapping region there in the middle, though, they represents the outcomes where both A and B occur. Now that we better understand what conditional probability is, now we can learn how to calculate it. So the formula here is spoken as the probability of A given B is equal to the probability of A and B divided by the probability of B. That is the formula for the calculations of conditional probability. We calculate this by firstly focusing on the situations where only B is happening. During this, you can reflect back to the Venn diagram to help you do your calculations. Secondly, out of those situations, how many also involve A happening? And thirdly, the ratio that you get out of those two questions gives you your answer, and that is the conditional probability.
Julie Hebert. I'm going to be explaining the purpose of Bayes' rule. So the purpose of Bayes' rule, it's a way to update what we believe when we get new information. It helps us figure out the most likely cause of something after we see the result. So for example, if we know how likely different programs are to crash and we see that a crash happened, Bayes' rule will let us work out backwards to find out which program was being used or was likely being used. It combines what we knew before or how likely each option was with how likely each one is to cause the result we saw. This rule is useful anytime we want to understand the chances of something being true after learning the evidence. So the pictures that I put here is like the prior probabilities right here. So there was 30% chance of it being orange, 10% of it being blue, and 60% of it being red. So that's the prior probability that we already know or how likely each option was. So we could use Bayes' rule to work backwards and figure out which one Cynthia used. And then the other diagram is just the step, like the orders of how we use Bayes' rules.
Hi, my name is Manuel, and I'll be explaining the four different types of probabilities that are included in the Bayes' rule, and also the generalization of the rule. First, we have PR of H, which is the probability of the hypothesis. Then we follow with PR of E, which is the probability of the evidence. Then next we have PR of H over E, which is probability of the hypothesis, which is conditional upon the evidence. And finally, we have PR of E over H, which is the probability of the evidence, which is conditional upon the hypothesis. With these four types of probabilities, we can now expand on the conditional probability formula. But we have to incorporate the rule of total probability, which is H and not H are mutually exclusive and exhaustive. Taking all this into account, we can now work out the formula for the Bayes' rule, which is PR of H over E is equal to PR of H times PR of E over H, which is over PR of H times PR of E over H plus PR not H times PR E over not H. That is the formula. There's two hypotheses, but to deal with multiple hypotheses, we have to generalize the rule. So in this case, we introduce symbol sigma, which allows us to sum up the terms of the substrate I. Now, given all this, we receive the generalized formula for the Bayes' rule, which is shown on the slide. and allows us to deal with any number of hypotheses, which are mutually exclusive and jointly exhaustive.
The total relevant probabilities to solve this problem is the probability of red, probability of orange, probability of blue, probability of crash red, probability of crash orange, and probability of crash blue, and the total probability of crash. To solve the problem using Bayes' rule, we must use the relevant probabilities that I just listed. There's 3 software packages, red, orange, and blue. The probability that Cynthia was assigned each program is based on how many employees were assigned to each. 6 out of 10 were assigned red, which gives us 0.6. 3 out of 10 were assigned orange, which gives us 0.3, and 1 out of 10 were assigned blue, which gives us 0.1. The probability that each program crashes was already given to us in the problem. Probability of red crashing came out to 0.1, probability of orange crashing came out to 0.2, and blue crashing came out to 0.3. We must use Bayes' rule to calculate the probability that she was assigned a specific program given that the crash occurred. To do this, we must calculate the total probability of a crash, which we can find by using the law of total probability. To find the probability that she was assigned blue, we have to apply Bayes' rule. This comes out to 0.3 times 0.1 divided by 0.15. This equals out to 0.2. With that, we also have to find the probability that she was assigned red given a crash. This comes out to 0.1 times 0.6 divided by 0.15, which equals out to 0.4. That being said, there's a 20% chance that she was using blue and a 40% chance that she was using red. Presented by Trinity Hart.
Building off of what Trinity said in the last slide, she very clearly explained and showed us how to calculate for problem 1. But just to reiterate, the final calculations of problem 1 would be, given that there was a crash, the probability that the vehicle was blue is 0.2. And given that there was a crash, the probability that the vehicle was red is 0.4. Thank you. Presented by Mauricio Martinez.